Hi everyone, welcome to the Neo4j stream. Today we are continuing on with building our travel site, our travel guide, I guess, travel guide site with Gatsby, Neo4j, and GraphQL. All the code is online. I'll drop the link in the chat here. There we go. Cool, so this is the third session. In the previous session, we looked at the different ways that Gatsby uses GraphQL as the source for creating content in a Gatsby site. And we started pulling in some data from Neo4j. So we've been using the Neo4j sandbox. Sandbox, I'm just grabbing the right link here. This one, so the OpenStreetMap sandbox. So you can use this link that I'll drop in the chat to create a new OpenStreetMap sandbox in Neo4j. So we've been using this data, which has data imported from OpenStreetMap of Central Park, and specifically points of interest in Central Park. And we saw how to pull that data from Neo4j through a GraphQL API. So we've been building this GraphQL API. If we take a look at our project, we have sort of two main pieces here. One is the Neo4j GraphQL project. This is where we are using the Neo4j GraphQL JS project to create a GraphQL API that talks to our Neo4j sandbox instance. And then we use Gatsby to pull this GraphQL API into the GraphQL API that Gatsby uses. So Gatsby is a static site generator that uses React and GraphQL and uses that content from the GraphQL API to create pages. So let's go ahead and fire up first our Neo4j GraphQL project. And we'll fire up our Gatsby site. Wrong directory. CD Gatsby site, Gatsby develop. Okay, so that'll start the Gatsby GraphQL API, pull in our Neo4j GraphQL API, and then build our site. So where we left off last time. Cool, so what are we gonna do today? Well, today I want to add two things to our site. The first is images. So we will pull data from the Mapillary API to find images that are actually showing these points of interest. We'll pull that into the Neo4j GraphQL API and then pull those images into Gatsby. And then the second thing that we'll do is some of our points of interest have references to Wikipedia pages. And so what we'll do is see how we can pull some information from Wikipedia to add as content into our Gatsby travel guide site. So if we take a look, point of interest connected to, let me make this a bit bigger first, there we go. Connected to OSM tag nodes, where exists t dot Wikipedia. Let's return some of those tags. It'll be OSM tags with an S. Yeah, there we go. So for example, remember we have our point of interest nodes, that those are the representation of the OpenStreetMap node that has things like the latitude and longitude, the timestamp when it was created, that kind of thing that maps to the OpenStreetMap way that we can use for routing and things like that. And then there's a tags node that has kind of arbitrary key value pairs with information for each point of interest. And so some of these have links to Wikipedia pages. So this is a statue of Balto. So if we go to Wikipedia, and let's go to a Wikipedia page, and if we search for Balto, and see that, oh, Balto is a sled dog, and that there's his statue in Central Park. So we want to be able to read about this kind of information in our travel guide. Okay, cool. So those are the two things that we're going to do today. Let's make sure, first of all, that we can see our site, localhost 8000. Cool. So last time, this is where we left off. We were pulling in just a list on the main page of all of our points of interest. And then we created a Gatsby page where we're using the OSM node ID. So basically the unique ID for each point of interest is the slug in the URL for that page. And we're bringing in the tags from the OSM tags node associated with that point of interest and showing that. If we go look at the code here, here's that tags field that we added last time to our GraphQL API that is doing that traversal in Cypher to populate this data. And then in our Gatsby site, if we look at the blog post template, which this is the React component that we're using to define basically this page. So this blog post template basically is rendered for each one of these pages, in our case, each one of these points of interest that we've pulled from the database. So to render this blog post page, we run this GraphQL API, this GraphQL query against the Gatsby GraphQL API. And then that data then gets passed in as props to this blog post template React component. It's the data prop. And then we use that to render this page, passing the data from the GraphQL query in as props to populate the content. So what we're going to do is first update our GraphQL API to pull in some third-party data from the Mapillary API, which is kind of like a crowdsourced Google Street View to find some of these images. And then we'll display that image on each point of interest page. The only other thing I want to do is make sure we have our Gatsby GraphQL API up and running, which we do. So there's two different GraphQL APIs that we're going to be working with. One is the Gatsby GraphQL API. So when we run Gatsby develop, that starts this Gatsby GraphQL API and then runs queries against that and uses that to render our site. But we also have, which we started over here, so running on port localhost 3003. This is our Neo4j GraphQL API that is talking directly to our Neo4j sandbox instance. And what we've done is using I think it's Gatsby source GraphQL. We did this last time, the Gatsby source GraphQL plugin to basically stitch this Neo4j GraphQL API into the Gatsby GraphQL API, sort of under this POI field here. So if we look at the POI query field, it's giving us points of interest. So basically stitching in our Neo4j GraphQL API into the GraphQL API that Gatsby uses to render content, which is pretty neat. That shows the power of the flexibility of GraphQL. Okay, cool. So here's our site. Let's go find some images to add into this. So I like to use Mapillary. Someone has to zoom in a little bit. Yeah, I'll remember to do that. So we'll make this page a bit bigger and zoom in here and zoom in a little bit on the code. Is that better? Yeah, thanks for reminding me. Okay, so Mapillary is kind of like crowdsourced Google Street View. So the idea is you download the iPhone app, or you can also use GoPros and other hardware, but you download the app and then go around, take pictures, upload those to Mapillary, and Mapillary sort of stitches together a bunch of crowdsourced photos of the world, right? And so you can sort of see the type of photos that people are uploading. It's also adding this data to OpenStreetMap, so mapping where roads and trails and things like that exist along with these photos. But Mapillary also has an API, which is what we're going to use today, that allows us to give a latitude and longitude and say, hey, find me some pictures at this latitude and longitude, and then we can display that in our application, which is pretty cool. They also have an embeddable widget, which we might look at as well. But for now, we'll just start with the photo. So if we look at the documentation, we are interested in finding images. So we're going to use this search images endpoint, passing in a location. So in this case, close to. So we want to say, find me a picture that's close to this latitude and longitude. And then the other one that's important is this look at. So not only do I want the picture to be close to some latitude and longitude, I want the camera to be pointed at the thing that I want to look at. And we can also specify a radius. So we can say only show me pictures that are up close. So hopefully for these points of interest in Central Park, I'm going to guess that Central Park is pretty well covered with Mapillary. I guess we'll find out. And I'm imagining people are wanting to map these points of interest, like, hey, here's a cool fountain. Let's get that on Mapillary. Okay, cool. So the first thing we need to do is register an application. If you saw when we were previously working on the real estate application that we did in a previous stream, we called that Willow. We used Mapillary there to find images of houses. I'll drop a link to this in the chat too. So this is a previous project we worked on. All the recordings from the streams are available there. So anyway, we used Mapillary previously to find images of houses, and that seemed to work okay for some cases. Of course, there were some houses that we couldn't find, but that's okay. Cool. So let's register our application. This is Central Perk, which is a travel guide of Central Park. Company name, company website, and callback URL. I don't think we really need that because we're not going to do any of the OAuth stuff. But just in case, we'll put that in there. So by default, we have access to all the public entities for searching images and stuff. We don't need to add any scopes because our application is not going to say like upload photos on my behalf or so on. So let's register that. So a question in the chat, is the Willow project finished? Yeah, that's a good question. It's not, I mean, in an application like this, you could probably keep adding features and improvements. I'll say it's functionally complete. So we went all the way, up to adding authorization and showing how to do mutations for adding listings and saving properties. There's some things I think we could add to it. I wanted to take a look at some recommendation queries. So now that we have the saved list, can we find other properties that you might be interested in? And I think we can improve our map component a little bit. So yeah, I think we might come back to the Willow project at some point to add some of those features, but I wanted to kind of kick off a new project with this Gatsby project since we were getting, up to, we had 10, 11 sessions from Willow. So didn't want people to get bored with us working on the same project. But yeah, if you clone it and build it, it should be functionally complete to give you a fairly good idea of what's going on there. Okay, so we've created our application. We've got a client ID, so let's copy that. That's what we're going, I don't know if I actually did copy that. That's what we're going to use to authenticate using this search images URL. Because I already did this with Willow, maybe we'll skip ahead a little bit and just take a look at GitHub, Johnny Montana, Willow, and maybe we'll just take a look at how we do this to see how we create the URL for that search endpoint. And so if we take a look at the source, we can see here that we're creating a custom resolver. Let me make this a bit bigger. A custom resolver for the photos field on the property type. So these, in GraphQL, these resolvers are the functions responsible for fetching data from the data layer for a given GraphQL request. And when we're using Neo4j GraphQL JS, so if we over here look at the code we have for our Gatsby site so far in Neo4j GraphQL index, all we've done here is define some type definitions and then call make augmented schema, which is actually generating the resolvers for us. So we haven't needed to create any resolvers yet. This Neo4j GraphQL JS library knows how to fetch that data from the database without us having to write resolvers. But there may be some custom logic that we want to implement where we may need to add code, some things we can't do, maybe with the Cypher directive. We'll look at later on when we add data with Wikipedia, we'll look at how we can add custom logic using the cipher directive, but for this Mapillary one, we're going to implement a custom resolver. Anyway, you can see what we're doing here is using this request URL to look for Mapillary photos. So let's take an example of one of these, just so we can see what's going on. And we'll try to do this in the browser. So we have a few parameters here. So per page, that's just the number of photos we're going to bring back. I don't know, let's do 10. We need to specify a radius. Let's say maybe 100. I think this is going to be in meters, 100 meters. And then we need a latitude and longitude. Let's do location, latitude, longitude. Let's get some points. We can start off with, sure, just this first one is fine. So a latitude is going to be this. And a longitude is going to be this. And I'm going to copy these two. Those are separated by a comma. I'm going to copy those two because this is for the close to parameter. But then we also need to specify that same point for the look at query parameter, since I want to make sure that the camera is pointed at that point, not just close to it. And then we need our client ID. Let's grab that again. Okay, so that should be a valid request to the Mapillary API to find some photos of, what is this, the Jacqueline Kennedy Onassis Reservoir. So here's the JSON result that comes back. This is GeoJSON. So we can see here that we have some features. So each feature is, in this case, going to be a photo. And we have a bunch of meta information about the photo. So it was taken with an Apple iPhone 10, the angle of the camera, the Mapillary user that created it. Oh yeah, let's zoom in here. Thanks for reminding me. And the latitude and longitude where the photo was taken, but we don't have a URL for the photo. What we have is a key. So if we go back, look at how we did this before. So there's different size images that we can create from the Mapillary API. So we just need to grab the photo key, so like the ID of the photo. Drop that in here. I think 640, I think should be a good enough size for us. And there's our image of the Jacqueline Kennedy Onassis Reservoir in Central Park, which, yep, that looks like a reservoir to me. Cool, so that one worked out pretty good. So let's add this to our, oops, don't need all those. Exit, don't need all those terminals, just trying to minimize that a bit. Let's add this now to our GraphQL API. So what we want to do is first add it to the type definitions. So we have a point of interest that has some fields. Let's add photos. That will be, previously we added a photos type when we did this for the real estate project, because I was thinking we could return some of the metadata and maybe do some post filtering or something. But I think here we're just really interested in the URL of the photos. So we'll just return a string list field for photos. And then because we're implementing a custom resolver, we're going to add the Neo4j ignore directive. There's a bit more information about what this is in the GrandStack docs. If we take a look at the directives page, this should be good. Yes, this page lists all the directives that you can use with Neo4j GraphQL JS. And Neo4j ignore is used to exclude fields or types from the cipher query generation process when implementing a custom resolver. So this just sort of says, hey, don't try to look in the database for a property called photos on the point of interest nodes, because there isn't going to be one. And instead, we're going to implement a custom resolver, which is like this. Cool. So we haven't created, we'll just do this all in the index.js file that keep things simple. So we haven't created a resolver map yet, so let's do that. So resolvers, this is going to be a map of functions. So every field on every property, or every field on every type rather, has a resolver. In some cases, there's just a default resolver which looks for a field of the matching name of the field returned by the previous resolver. So these resolvers are called in a nested fashion. For example, when we run this point of interest query, we start at the point of interest field on the query type, and then we call the nested resolvers iterating through the selection set. So we call the name resolver, the location resolver, then we call the latitude and longitude resolver on the location field. Now, with Neo4j GraphQL JS, because it's generating a single database query from the root, so most of the time, this generated point of interest resolver, so the root query field, is going to look ahead to see the full selection set and generate the database query that we're interested in. And then it's the default resolvers that actually get called to just select the name, location, latitude, longitude field from what's returned by the root resolver. So anyway, so that's why we structure our resolver map this way. So this will be the resolver on the point of interest type, and then specifically the photos field. And this is going to be really similar to what we did for the real estate for Willow, the search app. So it's going to be an async function because we're going to make a network request. And there are two things passed, or say two things that we're interested in that are passed into this resolver. The first, which we're going to call POI here, that is going to be what has been resolved so far from for this object. So if we take a look at this query, so we said that this point of interest query field, the resolver for that is going to fetch a bunch of data from the database. So all of that data that's already been fetched is going to be passed into this photos resolver in this POI. So POI, we're going to be able to access the latitude and longitude of the point of interest that we are going to be fetching photos for. And then in args, these are going to be any arguments of the query field. or not at the query field, of this photos field rather. And we didn't define any arguments in the type defs, but let's go ahead and add some. Let's add a, how about a first that is going to be an integer, and let's make that 10. So by default, we'll grab 10 photos. And then the other thing we can parameterize is the radius, which will also be an integer. Let's set that to 100. So remember, that's the radius of the point that we're passing from Mapillary to say find photos that were taken within, in this case, 100 meters of this location. And then those will be passed into our resolver function in this args object. Okay, and then what we're going to do is build up this request URL. I'm just going to copy this directly since we looked at what that looks like for the Mapillary API. So you can see here we're substituting a Mapillary key. Let's change this. It's not going to be property location longitude. It's going to be POI since we changed that. Oops. POI.location.longitude, POI.location.latitude, and POI location longitude, POI location latitude, and then args.radius and args.first. Cool. Then our response is going to be a call. We'll use Axios. We'll need to install that. npm install Axios. So Axios is a nice package for making network requests. It has a nice, simple API. And then that's going to give us an object like this that's going to come back from the Mapillary API. So the thing that we're interested in are the features. So response.data.features. So this array of feature objects. And then we'll map over that. So features.map. So for each element in that features array, the thing we're going to return, oops, missing a paren. There, yeah. The thing we're going to return is going to be this URL, so the URL of our photo, images, mapillary.com, v.properties.key. So that is this value. So we want to substitute this value in to this scheme for where these photos live on the Mapillary domain. Thumb 640 JPEG. And then when we call make augmented schema, we're passing our type defs, and now we're going to pass our resolvers. Cool. The other thing we need to do is add our Mapillary API key to our environment variables, which it looks like we already did. Cool. So now if we run npm run start, and now if we add photos, I need to refresh that so that GraphQL Playground picks up the type defs. Axios is not defined. Oh, right, let's import that. Axios equals request require Axios. And let's try that again. And now our query is going to be a little bit slower to resolve because now we need to go out to the Mapillary API for each point of interest that we're bringing back. So that's going to take a little bit of time. So here's a photo from Mapillary of the Jacqueline-Candido Onassis Reservoir. This should be the one that we looked at earlier. I think this was the first one we grabbed. Yeah, so that looks good. What else do we have? Let's find something else interesting. The pond, Richard Morris, I think that's a statue. NYPD. Christopher Columbus, the pool. Sure, let's look at the pool. Let's see how we do here. So here's another photo of a point of interest. That one, maybe not so much. That's someone riding on a bike, maybe. Anyway, we'll have to see if we get some good photos when we add these into our Gatsby site, which is what we can do now. So let's switch over now to our Gatsby site. So a question from James. What are the benefits of using Gatsby over just GrandStack templates? Yeah, that's a really good question. So Gatsby is a static site generator. I mean, it's really much more than just that. But basically with Gatsby, we can build all of the content for our site as static content using GraphQL and all the power of GraphQL to stitch together content from a bunch of different sources and generate static content, which we can then serve. So that means that since it's static content, it's going to load really, really fast. It doesn't have to hit a database or an API to load each page. And Gatsby also has a bunch of plugins. Gatsby, I think they have an interesting sort of visionary statement. Where was I seeing this? Yeah, their conceptual guide, I think, lays this out. And if you look at the Gatsby core philosophy, that talks about kind of building the building blocks and content mesh for creating web pages. So there's this plugin ecosystem. So far, we've looked at Gatsby source GraphQL for bringing in third-party GraphQL APIs, but they also have, so for example, a Gatsby image that has plugins for optimizing image sizes and that sort of thing. So there's a lot in Gatsby that we don't have out of the box in GrandStack or just in React. I would say fundamentally the main difference though is that you're building static content. So think of like server-side rendering, sort of pulling in the content for that via GraphQL. Later on, when we get to routing, though, we'll need to be able to do sort of dynamic queries to our GraphQL API so that we can find some routes that are going to be dependent on where the user is. So we'll see how to do that as well. Another question from the chat. I was playing around with GrandStack, liked everything about it until the moment tried to get everything up and running in Google Cloud. Love to have a template for that. Yeah, that's a good point. If you look at the GrandStack starter, it has it is all set up to be deployed to Netlify or Vercel. So there's Vercel JSON and Netlify TOML that has all the build instructions configured for deploying to either of those two services. For GCP, my colleague David wrote an example. Let's see if I can find it. For using Google Cloud Run. Yeah, here we go. So this article shows how to use Google Cloud Run to deploy a GrandStack application. So that might be, let's say, that's certainly one way to do it on GCP. I'll drop that link in the chat. That's one way to do it. You could also, I think, use, well, Google Cloud Run is kind of like a containerized serverless endpoint. So it sort of allows you to create serverless functions, in this case, basically just by wrapping a container. So in this example, we're running Neo4j GraphQL in a container. But I think you could also do this as a Google Cloud function. But yeah, that also works with Google Cloud Run. So anyway, hopefully that is a helpful resource for getting a GrandStack app running on GCP. All the code should be linked in that blog post as well, if you take a look at that. Cool. So we talked a bit about the difference of Gatsby and just sort of a regular GrandStack app. Talked a bit about Google Cloud Run. Right, what we wanted to do now is go back to our blog post template and let's update our GraphQL query to include photos. And where should we put our photos? So let's look at our site here. So if we look at, so this is the page. I don't think it makes sense to put photos on the main page because what I want to do, and I think we should be able to get to this in the next session, is replace this page with a map that has all of these points of interest annotated on the map with markers so we can see where these things are. So we won't put any photos on the front page. I think maybe what we should do is just put one photo on this blog page, maybe just below the H1 here. Maybe that's a good place. So image source is going to be post.photos, and that is an array. So we just want the first photo. Add an alt tag. Well, no, let's be a little more specific in our alts, since we can say that this is photo of post.name. Okay, it says cannot query field photos. Oh, right, we need to restart our Gatsby develop. We need to restart Gatsby so that it picks up the change in our Neo4j GraphQL API. So I got an error. Oh, let's do, ran into this last time. Let's do a Gatsby clean. So Gatsby, I think, caches. Gatsby caches a few things. I think the GraphQL, the Gatsby source GraphQL plugin, I think caches the introspection query for the GraphQL API. So this is now going to be a bit slower to build all our pages because now for every point of interest, it's going to the Mapillary API and getting 10 photos. Actually, we can change that. So we're not going to need 10 photos. Let's just get the first one because we're only showing one image, so no point in fetching a whole bunch. So while this is building, feel free to ask any questions you have in the chat. And while this is building, is there anything else we want to tweak? I think this should be good for photos. So we're going to show one photo for each point of interest on the detail page. And if this works, then we should be ready to move on to adding Wikipedia data. So missed the Medium link. Any chance of resharing it? Yeah, do you mean the link to the Google Cloud Run? I'm gonna close that. Google Cloud Run Grandstack. This one? Drop that in the chat. Cool. Okay, so that finished. So now if we refresh, hey, there we go. Now we've got this image of the Jacqueline Kennedy Onassis Reservoir in our page. Let's look at some other examples here. So Alice in Wonderland. Oh, cool, that one's pretty good. So we're zoomed in on the Alice in Wonderland statue. Some fountains. Yeah. Some of these I think are going to be better than others because, you know, they're Mapillary were meant to be kind of mapping the area and sort of stitching together a map, not necessarily. Oh, that one is a broken URL. That's not good. Group of bears. Yeah, here we're out in traffic. What else? Northwoods. Yeah, okay. So anyway, so we've got now at least a picture so we can see what the point of interest looks like. So that's neat. Let's now see how we can add Wikipedia data. I just saved my, what was my change there? Oh, my change was just this, just grabbing one photo. Okay, so we can see now that some of these have Wikipedia tags. We said that's stored in the database on these OSM tags nodes. So what we want to do is go out to Wikipedia and pull in some text that we can then bring in to our Gatsby page. There's a few different ways to do that. So if we look at a Wikipedia page, what do I have? One on the Black-Scholes option pricing model. Sure, that's a good one to look at. So we could maybe scrape the Wikipedia page directly. So if we sort of inspect the content here, I think everything starting down from this div that has the content text ID. We could do that using, we can actually do this in Cypher and APOC using APOC load HTML. So APOC is a standard library of procedures for Neo4j. So things that are ways to extend Cypher, basically. So here we're actually fetching some data from a Wikipedia page and grabbing some specific elements. In this case, we're grabbing all of the H2s. So we could do that. Wikipedia also has an API, which I took a look at, and I think, look at this page. So this is an example of getting the contents of a page through the MediaWiki API. I think this is an example. But we can, so here we're getting the unparsed text. I think, yeah, here we go. If we use the parse API, we can get actual HTML content. So here we could just fetch that content and load that in our Gatsby page since it's HTML. So a question in the chat, do you know if or how Neo4j can be used to communicate with other static data in Gatsby? For example, data coming from Gatsby plugin Shopify. Neo4j would be great for product recommendations. I'm not sure the best way to go about that use case. That's an interesting one. So in that case, I'm guessing Gatsby plugin Shopify is adding content into the Gatsby GraphQL API. So could you then query that GraphQL API to maybe load some data into Neo4j? Maybe that would be a way to go about that. I'm not sure. That would definitely be something interesting to look at. So I do agree that it seems like Neo4j would be great for adding product recommendations to a Gatsby site using, in this case, if you're already using the Shopify plugin. Yeah, that would be, maybe we can look at that in a future stream, seeing how we can make that happen. That would be very cool. So looking at our Wikipedia example, I think this is going to be kind of the route we want to go down, is using the API, because then we're not having to deal with sort of scraping the web page. We can just query the API and get HTML that we can then render directly. Yeah, maybe querying the Shopify GraphQL API directly. Yeah, that might be a way to do it. So maybe stitching together the Shopify GraphQL API and a Neo4j GraphQL API, and then using Gatsby source GraphQL to pull that, but combined data into Gatsby, kind of the way that we're doing it now. Yeah, that might be a better way to do it. What does the Shopify plugin do? Is that just wrapping the Shopify GraphQL API and making it available in Gatsby? I haven't looked at that. Let's take a look at that. Gatsby plugin Shopify. Source plugin for pulling data into Gatsby from Shopify stores via the storefront API. Yeah, it definitely looks interesting to explore. Yeah, add that to the list of Gatsby Neo4j things we can look at. Okay, cool. So we have an example of here we're pulling through the API pet door data from Wikipedia. Let's see how we can do this in Cypher. So what we're going to do is in our Neo4j GraphQL project, we're going to add a field. I'll do it here, so it's separate from our other Cypher directive fields. It's a bit more readable what's going on. So let's just call this Wikipedia. It's going to be a string, just a string of HTML. And we're going to create a Cypher directive field. And remember, these Cypher directive fields are where we can define some custom logic. So we're saying the result for this field, so Wikipedia on the point of interest type, is going to be bound to the result of some Cypher query. And in that Cypher query, we're going to use APOC load HTML to go out to the, or load JSON rather, to go out to the Wikipedia API and fetch that data from the Wikipedia page if it exists. So basically, if we take a step back of what we're covering today, is we're basically covering two different ways to build, or I should say, to add custom logic to our GraphQL API. The first way was by creating a custom resolver. And we did that to go to the Mapillary API. And now we're going to see how to do that, something very similar, in this case using just Cypher from within GraphQL. So I think we could have queried the Mapillary API using APOC as well, but it's good to look at different ways to do things. Okay, so let's write this in Neo4j first to make sure this is going to work. So it's going to be something like this, where we're matching a point of interest that is connected to an OSM tags node where t.wikipedia, let's look at a count and see how many of these actually have Wikipedia pages. 35. So not all of our points of interest have Wikipedia pages. That's okay. Let's bring through for now just one. So we're going to do this just for one point of interest, just to get this working. And what we're going to do, if we look in the documentation for APOC load JSON, we're going to say, let's see if there's an example here. APOC load JSON, we pass in a URL and we get back a map or an object where the JSON data is in, has been parsed and is in that object named value in this case. There's some other flavors of APOC load JSON, so we can do JSON params if we have some query parameters we want to add. We can also set the headers if we have like an authorization header or something like that. In our case, the API is open, so that should be pretty easy. I'll drop a link to the documentation for that in the chat here if you want to see more about using APOC. Okay, so we're going to say call APOC load JSON, and then we have the URL from not that one, not this one. Here it is. Yeah, so let's see what I want. Let's tweak the format here. And format equals JSON. There we go. Cool, so I think that is the URL we want. In the page, so page is the query parameter for the page we want to load. So let's pull that off to the end here, and what we'll do, page equals, let's do some string concatenation, and we're going to add on t.wikipedia. So that t.wikipedia, that has the Wikipedia page. Here's our Balto example. So for this case, the Wikipedia page we want is just Balto. Okay, and then we're going to, we need to say yield value. So this call to APOC load JSON is going to yield value, which is going to be a map or an object, which is going to be this. And then what we want to return is value dot parse dot text, because we want that HTML. Value dot parse dot text. And let's see if that works. Failed to invoke illegal character. Yeah, okay. So what we need to do is URL encode. So see, we've got spaces. So we need to URL encode that, which we can do in APOC, no problem. APOC has URL encode, I think it is. APOC Neo4j URL encode. Yeah, there we go. APOC text URL encode. So that's going to take out those spaces, replace them with valid characters that can be used in a URL. So apoc.text.url encode the Wikipedia piece. And another closed paren there. Let's give that a try. Cool, there we go. So now we've got back a bunch of HTML for, I don't know, whichever the first point of interest was, which, yep, Jacqueline Kennedy Onassis Reservoir again. Okay, cool. So let's copy this, because it's going to be pretty close to what we want to add to our GraphQL API. Let's get this decent indentation so it makes sense. Okay, so instead of matching on P point of interest, we have a keyword on these cipher directive fields, this. So this refers to the current object that we're resolving. So this point of interest node that we're resolving. Traverse out to that OSM tags node. Let's get the direction on here. just go, it goes from the point of interest node to Balto. We also, so the reason I don't add a relationship type to this pattern is I think we had a different relationship for some reason. Yeah, so some of these are called associated. Sometimes associated, sometimes tags. I can't remember what the difference is. I think it has to do with how we had that structured during the import. Anyway, that's fine. We'll leave no direction and no relationship. That's fine. Well, we don't want to match both ways. There we go. Okay, so from this node to find the OSM tags, only in the case where we have Wikipedia, we can leave this here because we're only interested in one. I don't know if we find multiple tag nodes. I don't think we have any of those, but we want to make sure we don't. And then this bit stays the same. Okay, so we'll save that, jump to GraphQL Playground, we'll refresh that so it picks up our changes, and let's zoom in a bit. And now instead of photos, we'll say, give me Wikipedia. So now we should get, if any of these first 10 have Wikipedia pages, remember only 35 or so of our Wikipedia, of our points of interest had Wikipedia pages linked, but this first one does, so that looks good. This is Jack and Cadito Onassis Reservoir again, so the pond doesn't have one. The conservatory water, that does have one. Cool, good. Okay, so we're getting some results here. Cool. So now we want to add that to our Gatsby page. So we'll jump back to the blog post template, and we will update our GraphQL query to now include the Wikipedia field. And where should we put this? Well, how about, I think here, just we can create a div after our tags. So we have this HTML content. How are we going to render that? Well, Gatsby has a way to dangerously set inner HTML. So dangerously set inner HTML is a JavaScript thing. I'm not sure. This comes from React. Not sure what specific things Gatsby does for this, but let's give this a try. So we've got our div, and we can say dangerously set inner HTML is just going to be post.wikipedia. So let's save that, and we're going to need to do a Gatsby clean to remove the cache because we updated our Neo4j GraphQL API, and Gatsby needs to pick up those changes. And this will take a little bit to build because we need to go out to the Mapillary API. I think at this point that's probably what's taking the most time for building these pages. Scroll through the chat, see if I missed anything. So we talked about looking at product recommendations for the Shopify API. It's a great idea. Definitely add that to the list. We talk about deploying to Google using Cloud Run. Talked a bit about the Willow project. Cool. Don't think I missed anybody. But again, if you have any questions or thoughts, feel free to drop those in the chat. Okay, so what we should expect to see when this is loaded is we should expect the main index page should be the same, so just showing us lists of points of interest. But now when we click on one of those pages, in addition to the photo that we just added from Mapillary, we should see some content from Wikipedia. So since this is a travel guide, those are two pretty important things. We want to see pictures of what this point of interest looks like, and then we want to be able to read any information that that we have to learn the significance of this point of interest that we're going to go look at. If anyone has any ideas for things we could add to this project, definitely let us know. You know, we could take a look at things like adding user reviews. We're definitely going to add the routing. So we'll definitely add a map view and routing in the next one. But then beyond that, we can start to brainstorm other things we might want to add. Okay, did we finish? Got some warnings here from, I guess, my poorly written JSX. I've left a few things. Dangerously set. HTML must be in the form. Oh yeah, I forgot. Oops. Forgot this. Underscore HTML. Right, that's an object, so it needs another curly brace. Did that finish already? Hey, there we go. Okay, so here's our list of things. If we look at one in detail view, we see our image, we see our tags coming from the database, and now we're pulling in some data from Wikipedia. So we can learn all about how this reservoir was built. Cool. What are some others? This one does not have a Wikipedia page. What else? Crime Busters Rock? Nope. That does not have a Wikipedia page. What else? What else should? Alexander Hamilton statue. Yep, he's got some Wikipedia info. This is just, I guess, the general Wikipedia page for Alexander Hamilton, not necessarily just the statue. I guess that's good to include that in a travel guide. That's kind of the thing I would want to know more about. What else? Group of bears? Nope. Family Morris, cool. So there's a good one. So you can see lots of info from Wikipedia, image of the statue. Now we have a map to see where it is, links to other points of interest in Central Park. That's cool. This one is a redirect, so I guess that link is a bit out of date from OpenStreetMap. Cool. Well, that looks okay for some of the points of interest. The points of interest, anyway, that indicated that they had a Wikipedia page. From the chat, I thought it'd be cool to show how schema stitching works between Shopify API and Neo4j. Yeah, we can definitely try to get that working. Cool. Well, I think that we have accomplished what we set out to do today. We said our goals were to add photos from the Mapillary API, which we've got here, and to add data from Wikipedia for the pages that have them, which we've got here. So I think that's good enough for today. I'll push these changes up to GitHub, and we'll also share the recording of this stream as well. So just to kind of reiterate what we did today, well, we added two things to our Neo4j GraphQL API. The first was adding photos. So we added this photos field and added the Neo4j ignore directive on it, saying we're going to build a custom resolver, which we did here. And in the custom resolver, we called out to the Mapillary API to find photos at some point. So wherever this point of interest is, find a photo of that point of interest. And then we added that into the Gatsby page by just adding that to the GraphQL query and then rendering that just in an image tag. And then the other thing we did is using now a cipher directive field in our GraphQL API, we use the APOC load JSON procedure to call out to the Wikipedia API to fetch Wikipedia data for the point of interest. And then similarly in Gatsby, well, down here, we just add that field to the Gatsby GraphQL query in our blog template that is responsible for fetching the data for each blog post. And we use the dangerously set inner HTML function here, or I guess that's a prop in React parlance, to set the HTML content of this div. So we add in some HTML content there with the data from Wikipedia. Cool, so next time I want to take a look at adding a map component, and there's two stages to that, I guess. One, I don't know if we'll get through it all in one stream, but one, I want to add a map component here with markers for each of these points of interest so we can see where they are. And then I want to be able to look at routing. So I'm at one point of interest, I want to get to the other. We'll use some graph algorithms to do efficient shortest path routing using the OpenStreetMap data that we have. Because this data set that we looked at is quite rich. We look at the db.schema. It's quite rich. We have a lot more than just point of interest. We have basically all of the OpenStreetMap ways, so all of the roads, bike paths, sidewalks, and so on. We have all of that in this data set for Central Park, and we have a routing graph on top of that, and we can then do very efficient graph algorithms for finding the best way from one point of interest to the other, and we want to show that on the map as well. So anyway, that's where we will pick up next time, which will be next Thursday at 2 p.m. Pacific. So thanks for joining today, and we'll see you all next week. Cheers.